Hi everyone, thanks for joining me again on my YouTube channel. First up on today's victim list, GPS devices. Many of us have them, and sure, our phones can do all this now, but dedicated GPS units can be great for flying by instrument type conditions such as dark nights or adverse weather, especially in unfamiliar remote areas where phone data may not be reliable. Normally we turn on the GPS device, and after a brief boot delay we get this if the device is being powered up for the first time. Side note, if you ever want something explained in pedantic detail until you hate life itself, one way is to ask an engineer to describe it to you. The other way, of course, is to ask a lawyer. In Garmin's case, they must have asked at least 3 or 4 in order to reach this mess. Okay, enough of that. Here's what we really came to see, a map. Why the earlier stuff? Well, it's because this Garmin Drive 51 device is new. Our previous 2-year-old Garmin Drive 5 suddenly quit working after a couple years and only showed the boot screen. It was then killed on the operating table by surgical malpractice, but today it receives a long overdue autopsy. The Drive 5 in turn replaced a very old Garmin Nuvi 205 that suddenly dumped its map memory all one fine afternoon in the middle of rural Nebraska. Albeit that one had a really long service life, can't complain. Still boots, but due to obsolescence it can no longer be updated using Garmin software. We will vivisect it in the name of science. Just a tiny amount of battery life, but if I leave it sitting here for a few minutes, it'll go out pretty quick. Let's start by taking a look at this one since it's already pulled apart. The shell's in 2 pieces, and you'd think it'd become apart fairly straightforward, but no, it's one of those clipped and snapped together things. Uses all these little plastic clips, and unless you know exactly where to poke and prod and push, it's very hard to pop it apart. Unfortunately, we now have a big tear there. See that? It's never coming back even if it had the possibility. So we'll just take a look and see what's inside here. Here's our main circuit board. Interestingly, both the battery and the speaker plug in on it. Here's the power button on the back. The power button comes in and it hits a button. Yeah, the power button clicks on that right there. But as for the rest of this, we have our USB Mini A port, the 2 connectors for the battery and the speaker. We have our micro SD card there for map expansions, and we have our GPS module and probably most of our main control right under here. There's I think that's probably a memory chip right there, and there's not a lot else to it. The connector where the display plug-in's right there, and that's pretty much all there is. Got this little speaker module in here. Interestingly, that's almost like the glue rings that are often put around cell phones. But yeah, there's our little speaker module. And then of course our battery, which is a lot like a cell phone battery pack. 570 milliamp hours. You'd think for what these things cost they could put a little bit more battery capacity in there than that, but I guess it didn't matter to me because I was usually running it with a DC adapter from the car. So yeah, not a lot else going on. I could, just for fun, try plugging it back in and see if anything boots, but I doubt it. I mean, the screen connector with all that damage, probably not going to get much out of it. These type of tiny connectors are very reminiscent of what you also deal with on laptops. Oh, hey, look at that. I got the screen to light up. That's as much as it's going to do. But now, just out of curiosity, let's see how that compares to one that's 10 years older. Now the question is, how is it going to pop apart? I see no screws whatsoever on this, so I think it's just going to have to be the application of force. There are a couple screws down there. They're under these labels. One right there. One right there. It's a little tiny, little tiny headset drive screws. I think I'm going to need something from my cell phone kit to actually get those out of there. Sure enough, there we go. Now let's see what we gotta deal with inside. I think inside here we just have normal Phillips screws. Yep. And now, once again, tied into a battery pack and a speaker. Looks like that speaker's just glued down. Yep. That battery pack I don't really want to try and mess with further. There we go. Take a look at that. Colorful if nothing else. But it's pretty much the same concept we had before. The other one's a little more efficient and miniaturized. I mean, comparing the two side by side. You can see how much smaller they got the circuit board on this one compared to this one. But I think we have most of our GPU hidden under there and GPS. And I can't even see the memory module. It's all underneath shielding on this one. So yeah, I can still turn it on and off. Just doesn't do much after it boots. Okay, this here is the remnants of a Cuisinart coffee burr grinder. My wife actually had it before we were even married. We then promptly ran it into the ground. I'm responsible for a lot of that, especially this year with COVID going on. I've been making all my coffee at home. It was working fine, and then it started kind of going kind of thing and not really latching in. And I tore it down. It was quite a piece of work. I didn't film it. Some of the parts around here were actually plastic welded together so that coffee beans could not possibly infiltrate down past the burr grinder into the motor assembly right here. But in order to show you what this thing is doing, I first have to bridge a little gap right here on the board because there was originally a protection switch here. Two of them actually. One that would disable the grinder if you removed the top hopper, and another one that would disable the grinder if you removed the little carafe that caught the grounds, whatever that thing's called. So I'm going to go ahead and plug this in. Again, this is a ground fault outlet. There is exposed 120 volt AC on here. Don't try this at home unless you're willing to risk the electric shock, but I didn't tell you to do that. That's on you. So here's the motor. Again, there are hot parts here I do not want to be touching. And then here's the control board. And let's just see what happens. I'm just going to put this, I have the switch here, I'll just set it on like a 4-cup setting. And I'm just going to touch that right there and press start. Yeah, that doesn't really sound right. It's kind of like, boop, 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 and if I let go, it doesn't run out the time slot. It's supposed to be going. What I found out with playing with it, now if I let it run like this for a while, and I'm not going to because I don't want to sit here and hold this with hot 120 volt going on. But I tried clamping that in the vise so that I didn't have to like be playing with hot parts and was able to just manipulate this for a while. And eventually I could get it back up to speed. And then once I got it back up to speed, for whatever reason, it would work normally until the circuit board cooled down again. Let's go ahead and unplug this. Just look at the front and the back side here. On the front here, there's not a lot going on. I have this interface to the control switch. And really, it looks like there's just the, here's one of the limit switches actually that was originally in the circuit that I bridged with that jumper. Control switch and the slider, I'd have to trace them out to figure out exactly what the scheme is on that, how it's determining the start button versus the runtime. But in any case, that comes back here. This is mostly passives on the top, except for this drive transistor, which is actually running the motor. Actually, that's not a transistor. That's probably going to be a triac, like you'd find in a dimmer switch, except in this case, it wouldn't be controlling the speed. It'd just be on or off. But then on the back side, we do have some sort of tiny IC there that's controlling it, along with some supporting surface mount hardware. Get a little bit closer look at that. My suspicion, it could be this capacitor here, but the capacitor is not showing any signs of actually being dried out or leaking. And I think that's just a power buffer. And the fact that it starts working again when it gets warm, might be the capacitor, but I'm really suspecting that this chip just up and died. It probably has, you know, run hot over time and finally just gave up the ghost, and so now it's buggy, but hard to know for sure. Not really worth trying to repair. I basically had to destroy the plastic welded components to even get this out of here. But it turns out this is a nice 120 volt motor, so I'll probably reuse that in a project. I did wonder if, hey, what if the motor brushes are going? Just to show you what those are, I can pull these out. But first, let's fire this up one more time, except look at it a little closer. Yeah, there, now you can kind of see the sparks going on in the brushes. What's happening is, in order to maintain the rotating magnetic field, little connections go into the winding keep swapping off between the poles. And the way they do that, yeah, that little brush contactor in there on the rotor, it has different little sections, so it's constantly trading off which connections it's making back to the source inputs. And the way it does that, if you've never taken a motor apart before, is with these brushes. And again, I am unplugged. Let's go ahead and just remove one of these carefully, because the brush behind there is spring-loaded and it'll just come flying out if I let it roam free. Okay, there it is. Now that actually looks pretty good. I mean, if it was worn down to, you know, maybe there, I'd be worried that it didn't have enough spring pressure, but that doesn't look bad at all. And it's the same on both sides, but the way the motor brush works is it's got this little brass contact on the outside here that actually makes connection with this piece that's sitting on top. And then spring pressure pushes the brush down against that rotating pickup, and then also presses this up here against the contact. And I pulled out both sides already, so I'm not going to do the other one. It looks exactly the same. But if you ever have a motor that's having trouble starting or kind of glitching, sometimes it could be that those brushes are just plain worn down, and you can buy replacements for those at, say, a hardware store or from a industrial supply. So there we go. The rest of this is dead and useless, but this is a nice little motor that I'll hang on to, and maybe someday I'll find a little project for it. The other thing, of course, you can look for in a motor like this that might tell you something was going on is a possibility of burnt coils. And I see what looks like at first a little darkening down there on some of those, but when I get my finger in there, it just comes off. So it's dust that's actually worn off the brushes. It's not a burnt motor coil. If they were kind of brown or black and it just came off sooty and the wire color didn't really change when you wiped it, then it wouldn't be dust from the brushes. It would be an actual motor winding burning out, which would explain why it was losing torque and having trouble starting. Brushes worn out? No, they're fine. Motor winding burnout? No. Bearings seized up? No. Motor's good, motor's reusable. Something on the control board is just gone batty. I had to destroy the coffee grinder to get it out of here, so I'm just going to junk the rest of this, but keep the motor for a future project. Okay, this here is a pair of handy-dandy LED light bulbs off of eBay. You do take a risk running these in your car because in most cases these are not certified by the Department of Transportation. Two things you can do that would help, one or the other. Some of these will actually come with a little cup shield that helps avoid reflecting light in the wrong directions. In this case, I found these are also useful because they cast light only side to side, assuming you get one of the two-way ones. Now, if you're shopping on eBay, you'll also see ones that are like three-sided or even four-sided. Don't. Once you put those in a conventional reflector, any light they fire downward will reflect off the reflector up into traffic. But if you go with these little two-way ones, they act fairly well good as a halogen filament point source because the light is in the same spot, very well concentrated. And on the sideways ones, it only casts mainly to the sides and then forward, which makes it easy to mimic the original factory beam and then adjust your headlights correctly. That being said, this may or may not be legal depending where you are, depending what kind of road inspections you have to pass, if any, at your own risk. Some of these have a little fan on the back for cooling, and some of them just try to use a bigger heatsink. These are the design that just tries to use a bigger heatsink, but sooner or later they fail. Sometimes they just plain quit working, but in the case of this pair, I had something really interesting happen. Let's go ahead and turn on this one here, which is the normal one. It's still at full brightness, using this handy-dandy power supply way back from our very first video. A lot of light in a small package. Great. Except that I noticed on the car I was using these in, right headlight, even though it's coming on and it looked fine externally, on the road there just didn't seem to be as much light there. So I wasn't quite sure what was going on about that, but I went ahead and swapped them out thinking there's got to be an issue with that one, and then brought these into the bench. Notice how we don't have the blazing light of the sun coming off that. It still looks plenty bright, but it's putting out way less than the original amount of light. That one there, I can almost turn it down to where we can look at it. So, yeah, dead, defective, and I mean, they do get plenty hot in operation. They also suffer a lot of vibrations because they're, you know, installed in a car. So it's fair that they go bad eventually. Well, let's not stop there. It's fun to see what's inside these. The only problem is they usually have a lot of potting compound in there, and it takes a while to really work them apart. But just to give you an idea, I can go ahead and start popping one of these apart to show you where to begin. In this case, that unscrews. With that unscrewed, I can remove this cover. Some have this, some don't, but once this cover's off, it's pretty common for them to have these two little pieces right here. Oh, that one's just Phillips. I don't need a specialty Allen or anything. Two Phillips screws come out, and then these two little pieces come out, and then after that I can also just remove the set screw to take off the headlight adapter. This one here is a 9006, I think, and so that's what this machined aluminum piece does. Nice thing about using 9006s in particular when you have a car that does it is the O-ring is built into the light right here, so you don't lose any weatherproofing, as opposed to those that rely on a rear slipcover for the weatherproofing. But in any case, there's a couple set screws you remove, and then all of this technically comes apart. But once you pop apart this rubber seal, it'll be full of potting compound back in here. So to show you what that looks like, I'm going to take another one that I had this happen on a couple of years ago and already disassembled. It's a very similar construction, and we'll take a look in there. Okay, so this is another pair I had, same construction. In this case, let's see, I got plus and minus on there? Sure. Let's go ahead and just fire this one up too to see if it still works. Yep, that one still works. This one, however, did not, and so at some point I took it apart to see what was up. And just as described, it's a very similar construction. So you do remove the top. And then this one has the screws on two opposite sides. There was one going in from this side, one going in from that side, which is actually pretty smart because that means all of these pieces can be identical, and then they just put them back to back, unlike that other one which required machining two separate pieces. Once that's apart, you can see the circuit boards that the LEDs are mounted on. This comes off and it just gets it out of the way. It's not critical one way or the other for this one. There's a set screw here that had to be loosened. Once that set screw was loosened, then I was able to unscrew this whole thing. So the heatsink comes off like that. And the final piece of the puzzle, this one I've already ripped the potting compound out of, so once I removed this weather seal, it was full of potting compound. But what happens is, the LED just slides off of there and it's back to back. And then there's the little control circuit in there, which I damaged when I got it out. Blew a chip right off of it right there. There was a coil there of some kind. But in any case, this one was just plain dead. It would not come on at all. So something had already burned out in it. But pretty slick little design. This one, most of these, even though they do technically have a positive and negative orientation in the car, some of them are made so that they're non-polarized. The little circuit in here doesn't care which way plus and minus come in. It'll just pick it up and start oscillating and then drive the LEDs. Really makes you appreciate the extent to which ordinary daily devices are full of electronics. Hopefully you enjoyed that. We looked at a couple GPS devices, we looked at a coffee grinder, and we looked at an LED headlight bulb assembly. That's all for today, but next time we've got video footage already queued for a couple more devices that we were actually able to repair. So if you want to see what's inside, you're going to want to join us. Stay tuned for that one. Thanks. Has anyone seen my phone?